Hello!
How are you today? We hope that well.
On this day, let's talk about a very interesting topic of chemistry.
My name is Ines.
And I am Carrie, and together we will talk about this great molecule. We talk about a very useful molecule in the agricultural area, ammonium sulfate.
Let's start.
It's believed that crop production started between 6,000 to 10,000 years ago. More than 3,000 years ago, the Chinese and Greeks already used fertilizers in their crops. The first experiments with plants were developed by Jean-Baptiste van Helmont. Subsequently, several scientists discovered the importance of water and carbon dioxide in development of plants, and the other did contributions to the study of plant physiology. But it wasn't until 1906 that Fritz Haber had investigated the industrial synthesis of ammonia carried out via catalytic and at high pressure. In collaboration with Carl Bosch, he discovered a system of atmospheric nitrogen fixation on a large scale that allows to easily obtain ammonia from nitrogen and hydrogen using catalysts. Method currently known as the Haber-Bosch process. From 1913, ammonia became important in the manufacturing process of nitrogen fertilizer around the world.
The ammonium sulfate is a chemical compound with this formula.
It was one of the first nitrogen fertilizers used in crops. But let's focus on its molecular structure given the chemical reaction. There are two ammonia molecules in gaseous state that when combined with an ester acid, such as sulfuric acid, form ammonium salt. Talking about of every components of this molecule formed for two ammonium cations by one of sulfate anion, joined by a ionic bond. Because although they are covalent molecules, they have lots of opposite denotations. Now, we will talk about ammonia, specifically of the elements present in this molecule. Did you know that nitrogen is in the group 5A of the periodic table? We can also get his quantum number through its electronic configuration, specifically in its outer valence or orbital layer, but in this case, it's 1s2, 2s2, 2p3. We observe that its valence is 5. If we go a little further and visit the p orbital, we notice that its last electron is paramagnetic. That is to say that it's not paired with another electron. From there we can obtain its unique quantum description. And these are its periodic properties. Which give a broad description of where it is. So, we will talk about hydrogen. Located in the group 1A and the first level on the periodic table, we can also get its quantum number through its electronic configuration. In this case, it's only electron. And this is the unique quantum description from the hydrogen. Its periodic properties are the following. That give a unique identity to the element, hydrogen. United by a polar covalent bond, because the difference of electronegativity in their union it is 0.9 and the dipolar moment it is 1.46 device. The ammonia is a neutral molecule and we can verify it when carrying out of the formal charge exercise. Where we observe the following, remember that the calculation of the formal charge is given by this formula. If we calculate the formal charge of each of its atoms and add them together, we get 0. That's why we say it's a neutral molecule.
created using how to